Our next section is 1.6 called Relatively Speaking. We're going to be looking at more percents and conversion factors. So number 1 says find the relative difference if you win $5 million and get shorted by $10. Write as a fraction, not as a decimal. So we have this formula, new minus original over the original, which is what we use to find relative difference or the percent change. And what that new minus original is it is the difference so our relative difference is the difference over the original, the same thing as the new minus original over original. Okay, so in this case, we don't have a new minus original. We just have that we were shorted by $10. So the difference is going to be $10, but we were shorted, so we subtract. And the original amount is what you were supposed to get, $5 million. Okay? And so if we reduce that fraction, we get 1 over 500,000. Okay, so that is your relative difference. It asks us to convert it to a percent. So if we do that, if we divide, just use your calculator, we get 0.000002. Change that to a percent by moving the decimal 2 places to the right, and we get negative 0.0002%. Now, why did we go through that? Well, in the next part, we're going to continue looking at this. So, here's what we've got. It says, in a nutshell, Einstein's theory of relativity says that even the passage of time is not absolute, but rather is relative to your frame of reference. In this lesson, we'll study appropriate ways to compare numbers, focusing on the importance of relativity. Is it relative? Is it significant? Does it mean anything? Consider 2 scenarios. In scenario 1, I borrow $20 from you, and when it's time to pay up, I give you $10 instead. In scenario 2, back to that first example, you win a $5 million lottery, but you only get paid $4,999,990. In which scenario was the shortage significant? Okay, so in 2, we've already looked at you were owed $5 million, but you were shorted $10. And as a percent, we found that to be a very, very small percentage that we were shorted. Okay, but if I borrow $20 from you, then I owe you $20, right? But I only gave you $10, so again, I shorted you $10. But in this case, your shortage is by 50%. So which one of these is significant? Okay, well, the one here, you were shorted $10, but you still got $10 less than $5 million. Not a big deal, right? So this one is not significant. While if I borrowed 20 and only gave you 10, that's important, okay? Both Shauna and John found out that they're getting a $1,000 annual raise this year. John went out to celebrate, while Shauna yawned and said, yeah, whatever. What do you think might be the discrepancy for their reaction? So John liked that he was getting $1,000. Shauna didn't really care. So we could say that Shauna probably makes a lot more. So $1,000 to Shauna isn't as big as a deal. While John, if John makes, I don't know, $10,000 a year, then $11,000, well, that's a big jump. If Shauna makes $100,000 a year, $101,000 isn't a big deal. Next, your instructor tells you you're going to get an additional 2 points on a recent test or quiz. Describe when this would be great news and when it really wouldn't help you too much. Well, 2 points is a big deal if it's on a 5-point quiz. Right? But it's not as important if it's on a 200-point exam, right? So this might be a gift from your teacher, and it might just be something she said to make you get in a good mood. Which I suppose we do that sometimes. The U.S. federal budget deficit for 2011 was about $1.298 trillion. This means that the government spent almost $1.3 trillion more than it took on. If you round that up to 1.3 trillion, which seems perfectly harmless, you're actually looking at a difference of $2 billion where you've rounded that up. What's the relative difference between the actual number and the higher rounded amount? Okay, so we're going back to this new minus original over original. But in this case, we're taking the estimate, because that was our new amount, minus the actual, because that was the original amount, over the actual. Okay? So we've got 1.3 trillion minus 1.298 trillion. Over 1.298 trillion. And what it says in that hint there is basically you don't have to worry about all those zeros. Since it's all in trillions, you can just subtract your decimals there. 1.3 minus 1.298 and then divide by 1.298. So you get 0.002 over 1.298, which is 0.0015 or 0.15 of a percent. So discuss whether or not you think this difference is significant. Well, as far as the percentage is concerned, it's a small percentage. So it's not significant relative to the fact that we have large numbers here. But if you start to think about it, well, is $2 billion significant? Yeah. So it says it's up to you to decide whether or not this is significant. And in the math part of it, no. But in the real world, yeah, probably. A college football team won 5 games and lost 7 in 2014. Then turned that around, winning 7 games and losing 5 in 2015. At the same school, the basketball team won 10 of 34 games in 2014, and then won 15 of 34 the following year. Which team had the more significant improvement? Well, if you look at football, then there's only a 2-game difference there, where they won 5 and then they won 7. So it doesn't seem that significant. While with basketball, they won 10 and then 15, so it's a 5-game jump. But let's look at it a little more. So for the football team, new minus old over old. Okay, we're taking the wins. 7 minus 5 there. Okay. That's 2/5 or a 40% increase. Okay, so that's pretty good, right? For basketball, we're taking the wins again, so 15 minus 10 over 10. That's a 50% increase. So you can see here that the basketball team made a greater increase, and so you would think that that's more important. But think about the fact that basketball is still losing more games than they won, while in football they started winning more than they lost. So it makes a little bit difference how you compare then. So we can say the basketball team made a larger increase, however, they still lost more games than they won. So in actuality, the football teams was more significant. Okay. Okay, just a few more things we're going to look at here. So, in this last part of the lesson, we're going to look at more conversions. After moving into a new house, a couple wants to have a concrete patio poured to support a hot tub because, well, it's a hot tub, right? Cool. The plans call for a 14-foot by 16-foot slab of concrete that's 4 inches thick. Round any calculations to 2 decimals. Okay. How many cubic feet of concrete will be needed? Okay. We need it in feet, right? And we know that it's 4 inches thick. We've already got these in feet, but we need the inches in feet. Okay, so we're going to start by changing 4 feet or 4 inches to feet. Okay, we know that there's 1 foot in 12 inches. Notice as before, I can cancel out my inches. And so 4 divided by 12, 4 inches is 1/3 of a foot. Well, remember, now we've got everything in feet, okay? Remember that volume is length times width times height, because it says how many cubic feet of concrete. So we need all that size there. It's like filling up a rectangular area. So the length was 14 feet. The width was 16 feet. And the height, in this case it's depth, was 1/3 of a foot. Multiply those together, you get 74.67 feet cubed. Why did I say feet cubed? Well, feet times feet times feet, just like x times x times x, is feet cubed. Okay? And it's cubic feet. When we're talking about volume, it is cubic. Okay? So there's our volume. It says convert the volume of concrete to cubic yards. Okay? Well, first thing you need to know is that 1 yard cubed is not equal to 3 feet cubed. No, 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 no. Okay? 1 yard cubed is equal to 3 feet cubed. Notice the pause. Okay? So 1 yard is 3 feet. But 1 yard times 1 yard times 1 yard is 3 feet times 3 feet times 3 feet. Okay? So 3 feet cubed is actually 3 times 3 times 3, or 27 feet cubed. Okay? And we want to, so now we need to change our 74.67 cubic feet into cubic yards, it says. Okay, so now we know that 1 cubic yard is equivalent to 27 cubic feet. And so we can cancel out our cubic feet and take 74.67 divided by 27, and that means we have 2.77 cubic yards. The coolest thing about ordering ready-mix concrete is that a concrete mixer will show up at your house. Most companies require orders by the cubic yard. So the patio was estimated at 3 cubic yards. How much extra concrete was ordered? So if we ordered 3 cubic yards, but we only needed, was it 2.77 cubic yards, then we ordered more than we needed. We ordered 0.23 cubic yards extra. So maybe they've got some pavers that need to be, I don't know. But they have that extra regardless of whether they want it or not. Should the relative error in the amount of concrete be positive or negative? Yes, it's positive. We just found it. It is positive because the estimate was more than needed. So you come up with a positive difference. Find the relative error. Okay. So if we want to find the relative error, then we ordered 3 yards, but we only needed 2.77. New minus original, new minus original over original. That gives us 0.083 or 8.3%. So we have 8.3% more than we needed. And lastly, moving forward with this same problem, in 2015, the average cost for concrete was $140 per cubic yard. How much would be spent on concrete for the patio? Well, we said we were buying 3 cubic yards, right? At $140 per cubic yards, we just multiply by 3, is $420. Find the dollar value of the wasted concrete. So how much did we spend that we didn't use? So we didn't use 0.23. Multiply that by how much per yard. And so we spent $32.20 on concrete we didn't need. And that's the end of this lesson.